Section 4.3, to graph the other trig functions. The first two functions you want to start with are the cosecant function and the secant function. Let's recall how they relate to sine of theta and cosine of theta. Remember, they are reciprocals. So the sine of theta is 1 over cosecant theta. Cosecant theta, therefore, is 1 over sine theta. Cosine theta is 1 over secant theta, and secant theta is 1 over cosine theta. Now let's take a look and see how these two functions associate. This graph represents the sine function. If we take a look at the value between 0 and pi, or 180 degrees, there are constraints that are associated with those values. Here we start at 0 and end at 0, and in between we are limited to a height of a positive 1. But the cosecant function, at 0 it's undefined, so we're not allowed to have a value at that location. And also at pi, or 180 degrees, it's undefined. But in between those two values, its lowest value is 1, and the upper limit is unbounded. Now, when we go back to the sine function between pi and 2 pi, again, the constraints at pi and 2 pi are 0, and down below, its lowest limit is a negative 1, or the amplitude of 1. And if we return back to the cosecant function, at 180 or pi and 360 or 2 pi, again, we are undefined and no value is associated with those locations. But in between, the highest value it can be is a negative 1, and then it's unbounded negatively. This slide shows us the graph of the cosecant function. If I show this in relation to the sine function, this is what it would look like. At 0, the sine function is 0. And then at pi over 2, it would go to the amplitude of 1. Back to pi, it would be at 0. At 3 pi over 2, the amplitude is negative 1, and back to 2 pi. And then it would start its period over. But it looks like the cosecant function is going to be a U-shape, and it's going to start at the amplitudes of each part. So here, a positive 1, I generate a U-shape. At negative 1, I generate a U-shape. So if I could graph the sine function, then I should be able to generate the cosecant function from that original graph. That's going to be the same thing that happens with my cosine function. Recall that in the cosine function, I start off the origin at 1, and then I proceed to 0, back down to my amplitude at pi, and back to 3 pi over 2 at 0, until I get to 2 pi, where I get back to 1 again. So again, if I would just finish this, it's going to be the same procedure on the cosine function to generate the secant function. At the amplitudes, be it positive 1 or negative 1, I generate a U-shape from the cosine function to get my secant function. Well, let's take a look at the procedure to sketching the graph of cosecant and secant functions. Step 1 says to find the period and quarter points as we did with sine and cosine functions. There is no amplitude for cosecant and secant, but we want to find the amplitude as if it was the sine and cosine function. Then determine the phase shift and vertical shift as we did in the prior sections. That means moving it left or right and then up or down. Then what we want to do is to graph the reciprocal function, that is the cosine or sine function. Then what we want to do is graph a vertical asymptote, in other words, a vertical dashed line, and they always are going to be located at the x-intercepts. Then at the amplitudes of that sine or cosine function, we want to make a U-shape to represent our cosecant or secant function. In other words, swing an arc at the max points of the graphs of step 1. I will put this slide and the previous two slides under our group resources for chapter 4. For my first example, I want to start off with a basic function of y equals cosecant x. Let's use the procedure from the previous slide to graph this function. First, I want to find the amplitude. The amplitude is going to be the constant in front of my function, as usual, which is absolute value of 1 is 1. My period is as before, which is going to be 2 pi divided by b, and b is the constant of my interior part of the function, which is, this case, 1, so that's 2 pi. Same procedure as before to find my quarter point. I'm going to take my period, and I'm going to multiply it by 1/4, so therefore that's 2 pi times 1/4, and that will give me pi over 2. Then I want to create a graph and count by 1 over 2 pi until I get to my period of 2 pi, and graph the reciprocal function of cosecant x, which is the sine function. So let's start off with my y-axis, my x-axis. My amplitude is 1, and I'm going to count by pi over 2. So pi over 2, 2 pi over 2, or pi, 3 pi over 2, and finally 4 pi over 2, or 2 pi. Then I know that my sine function starts at 0, goes to 1, back to 0, down to -1, and back to 0, finishing with what I started. Then I complete the smooth curve. We have done this on many examples on previous sections. Now, the procedure goes as follows. I create asymptotes, or vertical dashed lines, at my x-intercepts. Then I create U-shapes at the amplitudes of my arcs. So here, I create my cosecant function. Let's check our solution using the calculator. Here I went to y equals, and the function y equals cosecant x can be entered as y equals 1 over sine x. Then I went to my window, and again my x min and max are my negative and positive periods. My scale is going to be my quarter point, but for my y min and max, I went a little above and below the amplitude just so I could see how the U-shapes look. Then I graphed, and it generated my U-shaped curves. Now what I did was second trace for calculate, and decided to test a value. I'm going to test here pi over 2. So second pi divided by 2, and I should get a value of 1, and I do. Therefore, my graph is correct. My next example, y equals 3 secant x. Let's start by finding the amplitude, which is the constant in front of my function, which is the absolute value of 3, which is 3. My period is going to be 2 pi divided by b. Here, b is 1, so my period is 2 pi. My quarter point is going to be 1/4 times my period, 2 pi times 1/4, which is pi over 2. Now what I want to do is to graph 3 cosine x. So I generate my y-axis and my x-axis. Amplitude of 3. And then I count by pi over 2 to complete the period of 2 pi. So pi over 2, 2 pi over 2, or pi, 3 pi over 2, and 4 pi over 2, or 2 pi. And I can even count to the negative end of negative pi over 2 and negative pi. We want to graph y equals 3 cosine x. I start off my origin at the amplitude, which is 3, and then go to 0, -3, 0, and I finish where I started, which is at 3. Then I complete a smooth curve. And I can even complete that on the negative end to help out. So now what I want to do is to graph the reciprocal function, or the function that I have, which is y equals 3 secant x. And when I do that, what I want to do is create a vertical asymptote at the x-intercepts. And then create a U-shape inside those asymptotes to see y equals 3 secant x. Let's verify our solution by using the calculator. Here our function is y equals 3 secant x. But when I enter this into the calculator, the constant in front of my function remains in the numerator. The secant function itself is 1 over cosine. Therefore, that's going to be 3 over cosine x. My window is very similar to the one we just had. Negative 2 pi, 2 pi. The scale is pi over 2. I did increase and decrease my min and max because my amplitude was 3. I graph, and then I check a solution, and I'm going to try a pi, and we should get a negative 3 to make sure that we're correct. Second, pi, enter, and I get a negative 3. Therefore, my graph is correct. Our next example, y equals 2 secant x over 2, really is y equals 2 secant 1/2 x. Now what we want to do is to solve this for actually 2 cosine 1/2 x. So the amplitude is equal to absolute value of 2, which is 2. The period is 2 pi over b, which in this case is 1/2, which equals 2 pi divided by 1/2, which equals 2 pi times 2, which equals 4 pi. Then the quarter point equals the period times 1/4, which is equal to pi. The amplitude is 2. My quarter point is pi, so I'm going to count by 1 pi to get to 4 pi. 1 pi, 2 pi, 3 pi, and 4 pi. I can also do that on the negative end. Let's recall that cosine starts off the origin at the amplitude. This is positive, so this will start at a positive 0, 2. Then we graph the function to 0, to the negative amplitude, back to 0, and finishing where I started at 2. We can also put that on the negative side, which goes to 0, negative 2, 0, and back to positive 2. And then we can just complete it with a smooth curve. Now let's graph y equals 2 secant 1/2 x. Recall that I have vertical asymptotes at the x-intercepts. So I'm going to drop my vertical asymptotes at those points. Then, at the maximum and minimum of each of those curves, I will generate a U-shaped curve. And those red graphs represent y equals 2 secant 1/2 x. Let's check our solution. So I'm going to plot this in my calculator. Here I graphed both the functions. Set my window as usual. Graph the function. You could see the original graph of cosine and also the graphs of the secant function. And then I checked a value. And here I'm going to try 2 pi. That should give me a negative 2. And it does. Therefore, my graph is correct.